Hi everyone, this video is about object-oriented programming in JavaScript. Let's get started. So in this lecture, we'll learn the following topics. We're going to learn what is object-oriented programming and what's the difference between what you got used to it until now, which is called functional programming. We're going to learn a little bit basics about how we use object-oriented or OOP in JavaScript. And then we're going to deep dive a little bit into some advanced object-oriented topics like inheritance and polymorphism. So, what is object-oriented programming? So, object-oriented programming is quite different from what you got used to. Some languages are fully implement this and enforce other programs to use this, like Java, for example, is a fully object-oriented languages. Some languages are not, like JavaScript, for example. And object-oriented programming is a different concept that lets you as a programmer think about writing code in an object world, which means that everything has some sort of object with properties and methods. Let me show you an example here. So you can see three examples from the real world. So we have door, car, and a student. So all those three are objects. We can call them as an objects in our object-oriented world. And those objects can have multiple properties. For example, a door can have color, size, its material, and whether it's open or not, which is can be changed. Car can have the make, the year, the color of the car, and maybe the current speed. And student can have name, age, the subject that he or her is learning, and the grades. So every object can have some properties that describes the object. And you can have multiple cars or multiple doors. So you can have multiple of the same kind of object with slightly different properties. And it's perfectly fine to have, for example, two cars with different color. And every object can also have some methods, some actions that you can perform on. For example, door, you can open door, you can close the door, you can change the lock. And car, you can accelerate, brake, turn on the lights. And students, the student can study, eat, sleep. So all of those concepts are coming from the real world, and it makes it much easier to think about programming when we attach some objects from the real world into our programming. And that's the concept about object-oriented programming, that everything is an object. And those objects can work together. This is, for example, how can they work together? A student here on the right, he might own a car, and a car has multiple doors. And a car is also driving on the road, and a student lives in a city. All of those are objects, and city can also have multiple roads in the city. So there are relations between all of those objects, and they can work together. And we'll see some examples in this video. How can we make use of it? So without further ado, let's get coding. Here I have already this setup of, on the left side you can see my JavaScript, and on the right side we have the console with Chrome that we can just test out things. So let's get started with just a simple function. We're not thinking object-oriented yet, we're getting there. So if we do a function, and we call the function create person, and we'll give it a name, an age, and maybe that's it for now. And this function is going to create an object, person, and this person will have name, will have age, the same like I gave it in the parameters of the function. And as well, let's define also some method to the person. For example, say hello. And say hello is going to be a function which will console log hello, my name is. And then, since we are using an object, we need to use the keyword this to refer to the correct object. So this is how we write a simple object. I'm pretty sure you're already familiar with the syntax. You already created this kind of object notations in JavaScript. And let's return this person. So now, if I go to my console, I can now use create person function, give it a name, and voila, we're getting a new person. So let's assign it to a property. I have this stats constant. It is now a fully operational JavaScript object. So we can use stats.name and stats.age. We can also change, for example. So, and we can also call the say hello method, which will give me the correct string in the console. We can also create another object, for example, and there we go. So now we have two objects, and clearly they're not the same. And every object is by its own, has its own properties and has its own method. So this way of writing the creation of the object is called something like a factory function. It is a function, but every time you call it, it creates something. That's why we call it a factory, because it's creating new and new objects. We can also have a slightly different way. How can we create objects in JavaScript? Another way is to have create person. Maybe I will give it some no, let's call it create person, and this I will rename. So we're going to have the same function header, create person, name and age. This time it's quite slightly different. This time I'm going to do only the following things. I'm going to do this.name equals name, and this.age equals age. And lastly, I'm going to copy this function over here. I'll call it say hello, and I'm going to paste it here. That's pretty the same function like this one. Now we have this special function. It's also called a constructor function. And as you can see, it doesn't return anything. Just define this, which we don't even know what this is in this context. I don't even know on which object this function is going to be operated on. However, in JavaScript, to use this kind of thing, we can use a new operator called the new operator. So if we write const, for example, then, and then we call new create person. This is a slightly different syntax from what we saw above. It is still going to create a new object. This is something called new binding, and this new keyword in JavaScript is actually going to force this create person to create a new object as its own instance. So then we can see that we still have the same behavior like before. So this is another way how to create objects, and in fact that was the only way how we could create multiple objects in JavaScript, in the older version of JavaScript before ECMAScript 6. And after we got ECMAScript 6, we got a whole new syntax which makes things a little bit more readable and more easy to use. And we're going to do this right now with an example. I'm going to delete this. I'm going to start from the beginning. So the new keyword that we got in ECMAScript 6 called class. Class is a reserved keyword in JavaScript. And after the class, you specify the name of the class. For example, let's define, I want to change something, I want to have a bank account class. This is an object that represents a bank account. And you can now maybe pause the video and think about what kind of properties you can make, or actions you can make with a bank account in the real world. Meanwhile, I'm going to continue defining the class. So what we have here? We have class and we have bank account. All classes must have a capital letter here. So writing like this is wrong. Also, writing like this is also wrong. It doesn't mean that it will not work. It will just not in the convention of how we write object-oriented programming. So all classes must have a capital letter at the beginning. So we have our bank account. And in every class, we have a constructor function, just like the create person we saw above. However, in the classes, we use the special keyword called constructor. Constructor, and this acts like a function, so it has a parenthesis here and a scope. So in the constructor, for example, when we create a new bank account, it kind of makes sense to specify the name of the account holder and maybe the initial amount. So let's call it holder name and the amount. And in the constructor, I can access the keyword this to set the holder name for the first time and to set the amount like this. So with this, we have a really small basic class in JavaScript. And let me show you how you're going to use this. In the console on the right, we're going to use the same like we did with the create person. For example, account number 1 will be new bank account. So with classes, we use the word new. And then we need to specify those two parameters, holder name and amount. Holder name, maybe some person, and the amount will be, let's start with 0. And once you write this, we have our first bank account, which belongs to Alex and has amount of 0. You can have another bank account, which belongs to Steve, for example. Yes, amount of 10 currency. And now we can have two accounts. So this is the second account. And those accounts we can access using the dot notation, dot amount, or we can also use the dot holder name. And we can also change the amount, for example, to set to 100. Now the amount is 100. So this is a basic class. Now I want to talk about a little bit of terminologies. In object-oriented, we're using something that is a little bit different terminology than functional programming. So I want to write this in the comments. So a class, you can look at this as a template or a blueprint to create many objects. So class is just to specify how does the object looks like and behaves, and you can create many different objects from this class. Now, if I create an object from this class, we call this an instance of a class. So my account, I'm writing is new bank account, so my account is an instance of a bank account class, maybe the bank account class, since we have only one. And my account has properties. So we're going to call these account holder name, and the amount, we're going to call this properties. Because property defines defines some sort of context that belongs to the object. And in a class, you can also define functions here, which we call those in object-oriented methods. So methods, what can the object do? And properties, how to describe or what the object is, for example. And in the context of bank account, in bank account we can have, for example, deposit. We can deposit money to the bank account, and this is a function that defines, or method that defines, a deposit. Note that we don't use the keyword function here. We just completely eliminate this, except that it looks just like function. So let's write our own deposit method. This method will actually add the money that I want to deposit to my current money in the bank account. So maybe I'll rename this into amount to deposit. And here we can use the keyword this to access the current amount. So this dot amount is the current amount in the bank account, and we just want to add to the amount of deposit, and that's it. We can also have another method called withdraw, which will allow the user, of course, withdraw some money. Amount to withdraw. And similarly, it will do the same. It only will decrease the money from the bank account. So now we have a fully small object with properties and methods, and even one instance over here. Let's try to deposit and withdraw some money into the bank account. I'm going to refresh the page, and we already have this my account, so I'm going to use this my account. If I now print the amount, I can see it's 10. I can, for example, deposit some money. Let's deposit 100. And since this method is void, doesn't return anything, I get here undefined, but it actually changed the property of the class. So now, if I check my account.amount, it is 110. I can also use withdraw to have the same effect. I can withdraw 40. And here, yeah, I have a small mistake. It should be like this. So now I have 10, and I can withdraw 5, and I'm left with 5. And classes are very useful because we can implement some logic into the deposit and withdraw functions. For example, we can not allow to withdraw more money than we have in the bank account. So to do this, we can just have a simple if. So if this dot amount is less than the amount I want to withdraw, then I can either do nothing, I can throw maybe an error, or maybe can do something else, like allow to withdraw just the money until the balance is 0. You can decide, as the person who implements the class, as the developer who implements the class, how this method should behave. So in my case, I think I'll just throw an error. I'll just throw an error, and I'll write something like not enough money on the account. If you try to test this, so my account, if you try to withdraw some money, we got an error. And it's really up to you, how can you implement this? And this is one of the strengths of object-oriented programming, that if I use deposit and withdraw methods, it's safer because there's some internal logic that is written to make the class more robust and to work correctly. You can maybe imagine some incorrect things that I can also do. I can maybe deposit a string and my class will probably break. So you can also add some checks to this one. And you can do many things with this class. So to recap, before our first exercise, a recap. So a class is a blueprint or a template which you can create many instances of from this class. And an instance is an object that has been created of the class. And two instances are usually different. They may have the same properties, but they are different. They are different in the JavaScript object level. There are different objects. And every class should have a constructor function. This function, by the way, is provided by default. If you don't write one, you can still call, but it will be not implemented, so you don't have to provide it. Let's check this out. By the way, when refreshing the page, I can use new bank account. This will work. It will probably define those properties as undefined, so it's maybe not the best idea to do this. So we have the constructor, and constructor defines the properties that the class will have. In this example, with two properties, the holder name and the amount in the account. And also a class can have multiple methods. That methods can work and change and interact with the class properties, as we saw here. So deposit adds some amount, and the withdraw reduces the amount. And now I think it's time to start our first exercise. So let's do our first exercise. The first exercise, I want you to create a class, a new class, person. The person will have the following properties. It will have first name, last name, it will have age, and also we're going to add those methods. We're going to have a method that's called getFullName, which returns the first name plus last name. And we're also going to have a method called happybirthday. This method increases the age by 1. And lastly, the last method that we want is to method say hello, console log a greeting message with name. So this is the exercise. Try to do it. Pause the video, do it yourself, and resume the video once you're done. Alright, so let me show you the solution for the first exercise. So we want a class called person. I'm going to add this in the below here. So class person and class person. We should have a constructor, so we can create a person with first name, last name, and age. And we should define the properties of the class here. So first name, last name, and the age. So we have a constructor with three properties already. Okay, that's good. I think we should before we continue, we should test that it works. We can see if we can create new person. Yes, and it works. So we can see all the properties defined correctly. Good, so let's continue. Let's start with the method sayHello. The method sayHello is quite simple. The method sayHello is just console logs some greeting messages like, hello, my name is, for example, this dot first name. This is a simple message. Let's have the second property now. The second property is get full name, and this function returns the full name of the person. So because it returns, we should use the word return this dot first name and this dot last name, like this. So this method just returns a string. And lastly, let's have the happy birthday method, which will simply increase the age by 1, just like that. Let's test the class. So I'm going to return here to the from. Let's see if we can use this. So let's create our first person, Danny. And now we can use the methods, like say hello. And hello, my name is Danny. Yes, it works. And we can also use get full name. Get full name returns us Danny Smith. And we can also check the happy birthday method to see that if his age is increased by 1. And indeed it works. So I can call this method a few times and we can see the age is indeed increased. So this was the solution for this exercise. I hope you managed to do this. One note that I want you to share with you, that in the say hello method, we can use, for example, instead of first name, we can use this dot last name as well. So I can have more formal, maybe greeting, and this will work. However, since we already defined a get full name here, why not just use it? Since this is still a method in our class, we can use it inside our class. The only thing we need to do is to call this. And if I just delete the string here, and all I need to do is to write this dot say hello, and since get full name, since get full name returns us a string, it will just immediately work with console log. And let's check it in action. I'm going to create our own object, and if I call Danny dot say hello, as you can see, my name is Danny Smith. So you can use the methods, the class's methods from different methods. It's perfectly fine, and it's actually very, very useful because it can save you a lot of code. Now let's continue with having something more interesting with our bank account. I'm going back to the bank account class that we defined earlier, and I'm going to maybe change it a little bit. When I look at the bank account, I see that we have the holder name, which probably contains some string of the name. However, we already defined a very, very nice class of a person here below. And why not, instead of having a holder name, you can also actually have a person object here instead of a string. So we can use, for example, I'll rename the holder name into holder, maybe account holder. And this one, I want it to be now a person object. I don't want to be a string anymore. I'll do some quick renaming here to change the holder name into account holder. And now we can use something very, very similar. We can now create. First of all, we can create a person. Let's create Danny here. We already have the person here. And we can create an account for Danny. Let's call it Danny's account. And we use again the keyword new bank account. And now instead of holder name, instead of a string, I will just pass an object, the whole Danny object here. It will start with 0. So now in Danny's account, the property itself is an object. So when I print Danny's account, you can see the properties. The amount is 0, and the account holder is a person. You can see in the Chrome that it's type of person. And you can see the full properties of Danny here, and as well as the methods. And it is very useful because then you can have Danny's account, dot account holder, and then you can, for example, print the name, or maybe you can say hello, and you can use the object from inside the bank account. And this concept called composition, because we're taking one class and putting it inside of another class. And it doesn't have to be an object. You can have an array, for example. Maybe a bank account can have multiple holders. So it's going to be an array of persons. Can be. And this is a very powerful concept in object-oriented programming, because then you work with objects and it's much nicer to work with objects than just with strings, for example. Next concept that I want to show you in object-oriented programming is something called read-only getter. So in the class person, we have the get full name here. And we know it works because if I define it here, yeah, we already have it here. So if I define it here, it works. However, it's a bit strange because I don't really like the name. It's get full name and it's a function. Could have been so nice if I could just use something like Danny.fullName. It would look much nicer, but it's undefined because it's not really a real property of this class. Now, one way to do this is we can define something like this and just maybe, combine those together. But it's not perfect, since if this person is going to change his name, then the full name is still going to be static, because the full name is defined only once during the constructor. So maybe you see the first name here, but it's static. It's not going to be changed. So we can use a very special keyword in JavaScript, and this keyword is called before the name of the method, and you can use the word get. When you use the word get, it simply changes the syntax a little bit. It doesn't do anything too fancy. It just changes the syntax. So now, when we have Danny here, if I call get full name like this, it will not work, because get full name now behaves like a property. So you can see that you can call the same function, only without the parentheses. This is the only thing that this get keyword does. Another thing, that since we have the get here, maybe we can drop the get full name and just call it full name, just like that. And now we have even nicer syntax, because now we can just use Danny.full name. And if we change the last name, for example, the get full name is getting updated, because it takes every time the most current first and last names. This is exactly what the get prefix is doing. You don't have to use this. You can totally continue call it get full name just like that. But this is just for the syntax to make it much nicer. I'm going to keep this because the get has a brother, and it's called set. Which means that since it looks like a property, you might want to do something like this. You want to change the full name. In some cases, it is possible. However, in my case, I don't want anyone to change the full name at one go, because if it has multiple spaces, I don't know where the first or the last name starts or ends. So I want to disallow this. At the moment, this setter, it doesn't do anything, because it's empty and we didn't define it. It's not going to change anything at all, as you can see here. What we can do is we can either implement the setter and make it change the name, but I don't want to do it. I want to make it read-only property. So what we can do is just throw an error that we can full name is a read-only property. So now, every time that someone else is trying to change the setter, yeah, so of course you need to have like new value here. But we're not going to use this. This is just for syntax. You have to, when you specify a set, you also have to specify exactly one parameter. We're not going to use this. So we're just throwing an error. In our case, if we're going to try again, we're going to create the Danny, and I'm going to get the full name. This works. If I try to set the full name to something else, I'll get this error. Full name is read-only. So I'm happy about this implementation. Another way that we can do it, we can, for example, use the get and the set is in the bank account. So now, when I create a bank account, let's create Danny. I think I'll create those below so that it will always have those. Now we have Danny's account here, which is a bank account instance of a bank account class. We can, however, unfortunately, we can access the amount here, and we can also change it because it's still a property, and you can change a property as much as you want, and no one will stop you. You can also do something more scary, to do like something like this. This can even break all the behavior of the class because I'm assuming that the amount is a number. We can solve this using properties. If you go back to the bank account, we can have a property, a special property that called amount, just like before. This will get the amount, and we can also have a property that it sets the amount. You can either have those two or only get. You cannot have only set. So in this case, I want now to get amount. We need to return this dot amount. However, I'm having a problem because I've already defined an amount here and amount here, so it's going to be probably some sort of problem. So I'm going to rename this dot amount into something called underscore amount. Underscore amount, this is some sort of indication for myself that this is some sort of internal property, that I don't want anyone else to change it. And I'll write this down here. Mount is internal property. Or maybe I'm going to internal or maybe private. Some languages, they enforce no. Okay, so now that we have the amount property here, we can now use the amount like this. So we're returning the amount. If we want to get the amount, we're just returning our new internal property. However, in the set, I want to implement some logic. In the set, I want to do something like if the new amount is bigger than 0, then I'm going to set it. I'm going to set it into the internal property. Otherwise, you can either maybe throw an error, you can maybe do nothing. Let's do something, for example, if you try to set a negative number, it will just put a 0 there. Now we have this special amount property that it acts differently from this amount. And let me show you by example how it works. So we have Danny's bank account here. And now, if you notice, I still have this underscore amount, and I can still change it to whatever I want. And the reason for this is because JavaScript doesn't block any developers to do that. In some programming languages, you can define the property as something called private, and then this will never work. You'll never able to access this special internal amount. Here I'm indicating it with an underscore to maybe tell the developer that, hey, you shouldn't change this. You should keep this as is. And you should instead use this amount property, because this amount property is safer. It has some logic implemented to protect my class from some inconsistency. And this will work exactly the same, and maybe the developer that doesn't look at your class, he might even think that it's just a regular property. And if I try to set amount to 333, it will work. And if I try to set the amount to something negative, we should have 0, and it works. This is another example of get and set. This time we can also set, but we're having like additional checks here, just in case. You can also, for example, implement the get a little bit differently, maybe to get amount in different currencies. You can do this very easily, just having more get methods. Okay, I think it's time for a second exercise. And in this second exercise, I want you to add the following to the person class. I want you to add a gender property, and I want you to make it read-only. So I want you to do something very similar that I did with the amount, which means use underscore gender to have internal property, and use get set. Use get and set gender methods. This is what I mean. So I can, in my class, read the gender, but I cannot modify it. Yeah, and that's the exercise that I want you to do. So please spend now a few minutes to modify the person class and to add a new read-only property called gender. I just want to add another thing that you need to set it once in the constructor. Yeah, I think this is going to help you. All right, pause the video now, and we'll be back when you're done. Okay, so I hope you managed to do this exercise, and I'm going to show you the solution right now. So we're going back to our script and back to our person class. We're going to add a new gender property here. And usually what we would do is just to add a gender here, like this. And we have a gender property. And this will work. However, we don't want any outsider to change the .gender. So the way we do this, we can do a very similar way to what we did here above with the amount. So we can have this private gender, which we're going to set once, only once, in the constructor. And then we can define get gender and maybe set gender. Since I want it to be read-only, I'll throw an error if you try to change the gender. And if I use get, then I'll just return the private gender. One common mistake is sometimes you think that you should do this, dot gender. However, this is wrong because this will call this getter once again. So you have like infinite loop here, a recursion that will call itself because this dot gender calls this function, and this dot gender, it calls the real property that we defined on the object right here. So this is a common mistake that you should try to avoid. And that's the solution for this exercise. Next topic that I want to discuss is about inheritance. So I'm going to start with this basic person object that we already have. So this person has first name, last name, and age, and it has a bunch of methods like happy birthday and say hello. I'm going to create a new class here. I'm going to call it student because I want a student class. I want a class that represents a student in maybe HackYourFuture. So let's call class student with a capital S, and we're going to define a constructor function. And I want the student to have a first name, last name, I want to have it age, and I want to have maybe the school name that he's enrolled into. And since those are properties, we can set those like this. So I have now a person and a student class, but something is not quite right for me. I see that student has 3 out of 4 properties exactly the same like a person, and I don't want to maybe duplicate those lines of code, and it's something I see that there is some sort of relation between student and a person. And this relation called inheritance because every student is also a person. So in this case, if every student is a person, then we can use inheritance in JavaScript to make a student inherit all those properties and all those methods from the person class. And to do this, JavaScript has a special keyword called extends. Extends, and after the extends, you must specify the class name that student extends. So class student extends person. It uses the word extends because we're taking the person class and we're making extension of it. We're making it bigger, more richer. Now that we have the class that is the student that is extends the person class, we now, if we try to run this, let's create a student. Let's maybe create it here. So first name, and school name will be HackYourFuture, of course. So we have our first student, and if I'll go here, I'm getting an error because my constructor is actually not correct. The error that I'm getting is that you must call super constructor in the derived class before accessing this. So first of all, a lot of new words. What is super constructor and what is derived class? So derived class is the class that inherits from something. So student is the derived class of a person. And super constructor, we'll see in a bit, is the constructor of the parent class. So this is the super constructor. In order to fix that, we don't need to duplicate all of those things because those setters, those first name, last name, and age, we already have those here. So what we can do, we can call the super constructor like this. This is a special keyword, super, which refers to the super class. It is something like this, but this is the current class. Super is the parent class. Since we have methods on the parent class, we also have a constructor. So I'm going to call the super class and use first name, last name, and age. And it kind of makes sense because in order to create a student, you need to first create a person. So this is how inheritance works in its core. You need to first create the parent class, let it set all the properties, and after that, I am configuring my own class. So this is configuring the superclass person, and after done, configuring the child class, we can call it student. And now I have this student, which is a student class. However, because it inherits from person, I can use a methods from person object, like say hello, and I'll get those for free. Say hello, yeah. Just need to make a small change here. There we go. It was a small bug, so the say hello we'll call the full name getter. So now when it says student1.sayHello, we have the method over here. So we get a lot of things for free. If you use inheritance, we get for free the methods, all the getters, all the settings, the methods. We also get the constructor for free, which might have some logic inside. And also we can define our own methods in the student class, which is perfectly fine. So we can have a method called, for example, study, and I'll just console log that first name is studying. So this is just a simple study method. Now let's see if it works. Yes, Emily is studying. So we can see that we can have another additional methods in this class. Important note to say that we can still create an instances from a person, and this will be perfectly fine, not a student. A person is not necessarily a student, so we don't need the school name. It only have 3 properties in the constructor. So now we have one student and one person, and if we try to use study on a person, it will not work. And the reason for this is study defined only in a student class. It doesn't define in a person class, so it doesn't go up. The inheritance only goes down from the parent class to the child class. And that's a key thing to remember about the inheritance. Another thing that we might do is we might change the existing properties of the parent class. So we have on the parent class sayHello method. Our child class, our student, can have its own sayHello method, which is different. And this is called overriding the parent class. So here, maybe instead of hello, I will say hi. My name is first name, and I study. Since we're in the student class, we have the school name. I'll study in. So we can have this. Let's check this out. So we have the student 1. And when we use say hello now, you're going to get the different message that we just defined. I think I'll do it like this. So now it's hi, my name is Emily Smith and I study in HackYourFuture. So the way it works is when you call a method on a class, it first goes to the child class to see if this method is defined. If it defines, it will use this method. And if not, for example, if I will call student1.happybirthday, JavaScript will try to look happy birthday here. It will not find it, then it will try the parent class. And in the parent class, we can see the happy birthday, So therefore, it is going to work. What you might also do is use the say hello, use the implementation of the parent class, because maybe you want to have this message here, right? So maybe you want to say hello, my name is full name, and then maybe you want another message. Let's change this. So say hello, we can use the existing message, and to use this, we can call super.sayHello. This is a different, this will call the say hello of the super class, and after that we can add our own message like, and I study in this.schoolname. Now when I refresh the page, you can see that if I use student1 to say hello, the first line, this line, if I see the line of code that is being executed from, it's line 10. So this is executed from the parent class, and the second line is being printed from the child class. And this is a very powerful tool, because since you're inheriting from class, you can definitely use its methods, and you can changing by overriding, and you can do a lot of useful things with this structure. What I want to stress out is how important is inheritance, and we can do something like this. So we have a person class, and we created a student class that inherits from the person. We can also write a teacher class which inherits from a person, and the student and the teacher classes, they will not have the same relation. So if we define the new method on the student class, it will not be on the teacher class, but those two child classes, they will get the person classes methods and properties. And it kind of makes sense from the real world, because every student is a person, and as well every teacher is a person. However, it's not true that every student is also a teacher, or every teacher is also a student. So there's no relation there. And another thing that I want to stress out, that every class can inherit only from one class. Student cannot inherit from two parent classes. It might not have more than one parent class. But this is not all. You can continue creating much more complex structure with object-oriented and inheritance. For example, a student might have two different child classes, like university student or high school student. You can maybe think that different properties between those two students. Maybe, in university they have the major, the faculty. High school students have maybe some other properties. And that's not all. You can also continue. You can also have something even more complex. You can have a medical professional, which is a person. It's not a teacher, it's not a student, it's just a person. And medical professional can be a doctor or a nurse, and doctor has different specialties. And this can become really complex. And this is also really powerful, because this dentist here in the bottom of the line, it will get all the methods and the properties of doctor, of medical professional, and person. And it kind of makes sense, because the dentist is a doctor, and is a medical professional, and is a person. And that's the basic concepts of inheritance and how important it is. And the last topic for this video, it's called polymorphism. And I just want to show you this by an example. So I want to create a few students, and maybe a few people as well. So we have student 1, student 2, student 3. We have person 1, person 2, person 3. So now that we have all those students and persons, I want to create an array of all of these. maybe people, or it can be a city or a country, and this is an array of all of these. So we have an array of people, and some of them are students, some of them just a person, and it's clearly there's a difference here. But there's something in common with everyone. And the thing is in common in everyone is they all have the say hello method. And this is something called polymorphism. And polymorphism allows us to call a lot of objects which are different. For example, here people have students, have persons, but they all have the same thing in common. For example, they all inherit from person, and which means they all have the say hello method. However, every time this for each runs, it will call say hello on the object, but the say hello will behave differently whether it's from a student class or whether it's from the parent class. So when it will be called on student 1, student 2, and student 3, it will use this method and it will use the school name. And when it will print this person 1, 2, and 3 say hello, it will not use this method because this method defines only on a person. So if I run this, you can see that we have those 3 messages are from student, and after that we can see 3 messages from a person class. And this is a really powerful tool in JavaScript, that if you have an array and you know something common about this array, for example, you know this array are all persons, doesn't matter if it's a doctor or a teacher or a student, but if all of those are inheriting from a person class, you can use on all of those blindly the methods that are defined on person, and they will work because they are inheriting those. And that's clearly something that is very powerful. For example, you can have an array of shapes, and the shape can be triangle, square, they can inherit from each other, but if all of those shapes, you can maybe call some method called draw to draw all the shapes. And that's a very interesting and powerful tool in object-oriented. So this concludes our video about object-oriented programming in JavaScript. I hope you learned about object-oriented and you understand how to use it. And thank you for watching the video. Have a great day.